writing equations from word problems. So in this example, we have 3 people, Shaquille, Lyle, and Amanda, and together, all together, we know that they have a total of 364 stamps. So my suggestion is to start out with an outline of Shaquille, Lyle, and Amanda have a total of 364 stamps, which means I should be able to add their 3 amounts and get 364. It gives us some extra information in the problem. Shaquille has 1/2 the number of stamps that Lyle has. He has half the amount that Lyle has. So I'll use an L to represent Lyle. Amanda, so let's go here below Amanda. Amanda has 2/3 as many stamps as Lyle. So again, we're writing Amanda's number of stamps in terms of Lyle. So now we can go back up to our equation outline and say, well, Shaquille has 1/2 L. If you'd rather use X, that's fine, but you need to know that your variable here does represent how many Lyle has, and you need to use an L in this equation to represent how many Lyle has, because again, you have all 3 of their stamps add up to 364. And then Amanda has 2/3 the amount of Lyle. So now we have an equation, 1/2 L plus L plus 2/3 L equals 364. We can combine like terms and solve. To combine like terms, this has a coefficient of 1. So I would start by adding 1, 1/2, and 2/3 to get a total for the coefficient of L. And then I would solve for there. But that's how you would set up the equation. Let's do another problem similar to that. So here, instead of talking about stamps, we're talking about how many pages 3 people are reading when they do a project. So again, my suggestion is always to start by saying, all right, well, we know that they decide to base the book on a project that is 540 pages long. So that represents my total. So they have to read a total of 540 pages. They're going to split this up. Raphael's going to read some. Denise is going to read some. And Philip is going to read some. But the amount they read, those 3 amounts, should add to 540. Denise will read 3/4 of the number of pages that Raphael reads. 3/4 of Raphael would be 3/4 R. Philip will read 1/2 of the number of pages that Raphael reads. So R is going to be our variable, what we're solving for. And then we can come up and say that R plus 3/4 R plus 1/2 R, that is what we would use to represent how many each person uses, and that has to have a sum of 540. So using the variable R, you do have to include the R because that represents how many Raphael reads, and he is one of the 3 people reading pages. So that will, solving this equation, will find how many Raphael reads. Now, remember, if they asked you here, they do ask how many Raphael reads. Sometimes they may mix it up, though, and say, oh, how many pages does Philip read? Well, you still would have to write your equation in terms of R, solve for R, and then once you know R, you would be able to go back and substitute that and figure out, well, half of that is the amount that Philip reads. So you do have to read carefully for what they're asking for. On that note, going back to this first example, I noticed that when we look at this example, it does say, how many stamps does Amanda own? So what did our variable represent in the equation? And that's why it's important, if you're going to use x, to make sure you define what the x represents. And since all of what they're giving me is in terms of what Lyle has, we let our variable represent Lyle. And that's why I used L, because it kind of makes sense that that's Lyle's number of stamps. So when we solve this equation, we would end up getting what L equals. But that is not what the question asks. So you can't just solve the equation and think you're done. You need to know, what does my variable represent? Solve the equation and know what you're finding. I'm finding the number of stamps Lyle owns. Then go back and use the information, which if you wrote the problem clearly like this, you would easily be able to see, okay, well, Amanda has 2/3 of Lyle. So whatever I found to represent the amount of stamps Lyle has, I multiply that by 2/3, and that would tell me the amount of stamps Amanda has.